For number 1, we want to label our points X and Y. And we want to plug them into the system over here to see if it works in both of them. So if 1, 1 works in this equation but doesn't work in this equation, then it's not my solution. I need to try another point. So we're going to go ahead and start plugging in the 1 for X and Y. So 2 times 1 plus 1. I want to know, does that equal 3? And it does. So I have 2 plus 1 is 3. We know that 1, 1 works so far. But I can't put that answer down unless I know it works in the second one. So I'm going to plug that equation, or that 1, 1 into this equation. So we get 1 minus 2 equals negative 1, which is true. That becomes negative 1. So that means that my solution A, 1, 1, works in both equations. So it's the solution to the system. For this system of equations, they went ahead and graphed the two equations, and we want to know what point do they meet at. So that point is simply negative 3, 3. In number 3, we could do the same thing we did in number 1. We could make X and Y, and then we could plug them in to see which one it works in. We also could use substitution method where we have Y already by itself, and we plug this into Y. I honestly think it'd probably be a little bit faster just to plug in our points. So if I plug in 0, 4 to here, 3 times 0 plus 4, does that equal 6? No, because 0 plus 4 is not 6. Okay, so then I'm going to try 2, 0. So 3 times 2 plus 0, does that equal 6? Yes. 6 plus 0 is 0. Works. So now I'm going to try 2, 0 in this equation. So y is 0. X is 2 minus 2. So 2 minus 2 is 0. It works. So that means that B, 2, 0, is my solution. For number 4, we need to figure out the two equations, or the two inequalities. I think it would be helpful to mark your y-axis. So here's the y-axis. Okay. And then here is the x-axis. It's labeled X here for you. Okay. So on the line, on the y-axis, we can see that this darker line here, the solid line, crosses right here, which this is 0, so 1, 2, 3. This is 3. Okay. It only looks like this one has a 3 as my intercept. So 3, and then the next point on this line is right here. So if I go up 1 over 2, that's my slope. And in order to get this darker shaded area, that means that from this line they had to shade down. Okay? If they shaded this down, like so, that's less than. And because that's a solid line, you have to have the equal to part. So right now, the only equation that follows that is this one here. Okay. Secondly, the dashed line here, it crosses the y-axis at negative 2. And if we find a point, looks like right here, it can go to, for our slope, we can go up 3 over 1. Up 3 over 1 is just 3. Okay, now this blue line, or this dashed line, we see that, again, this is the darker area, so that had a shade up, which is greater. And in this case, since it's solid, or sorry, since it's dashed, we don't have to have the line there. So if we match up, it would be letter A. Okay, again, I would probably look for things like my y-intercept, if your lines are dashed and solid, to see which one it would go with. And then for number 5, it wants to know which one is no solution. That is A, because your lines are parallel.